Hi, welcome to Physics Teacher. In this video, I'm going to go over a lab that I do with my grade 11 physics students on specific heat capacity. So we have two different metals, and we're going to try and determine what those metals are. And this is how we're going to do it. I'm going to boil water, place the metal in the boiling water for a couple minutes so that I could reasonably assume the metal has reached a temperature of 100 degrees. Then I will take the metal out and put it in a cup of water that has a small amount of water at room temperature. And then with this temperature probe, we will watch to see how that temperature is changing so that we can record the final temperature that the metal and the water together reach in equilibrium. Knowing the mass of both the metal and this water and the change in temperature, so I need the initial and final temperatures of both, we can calculate the specific heat capacity for that metal. Now, if you want to see a video or a tutorial on that calculation, I have one here where I go over a sample problem of that. Once we're done with that, we can get started with our lab. All right, so let's start by preheating this water. And while that's heating, we're going to start with this metal first. So let's check out first the mass of this metal. And we get 69.1 grams, right? 69.1 grams. Now we need to know the mass of water. Now currently there's nothing in this. So let's just figure out what the mass of the cup is. It's exactly 3.0 grams. And now we'll add some water. So now we've got some water in it. And it is 78.7 grams. So subtract 3 grams, the mass of the cup, and we'll know the mass of the water. All right, so we got the water boiling. So let's put in our metal. And we'll leave it in there for about a minute or two so that we can reasonably say that the metal has reached a temperature of 100 degrees. And that'll be our initial temperature for the metal. And while that's heating up, let's start our recording. So we'll put the probe in the water so that we can get an initial temperature of the water. So it's going to immediately start graphing. Okay, so this is really boiling, so let's just turn it down a bit. Looks like the initial temperature of the water is about 20.2 degrees. So now what we're going to do is we're going to take out the metal, put it in here, trying to avoid touching the probe. If the metal comes into direct contact with the probe, you're going to get a huge spike. Okay, and now we'll just stir. We'll watch how that temperature changes. I think that's pretty good. So we've reached a final equilibrium temperature of 25.9 degrees. All right, so you can let me know in the comments what metal that is when you've done your calculations. And let's get started with the next metal. So this is our next metal. Let's start by checking its mass. So it has a mass of 69.9 grams. Let's heat it up in the water to 100 degrees. And we'll also reset this. So remember, we're going to use the same cup, which I believe was 3 grams. And I've got some fresh water from the tap. And so together they have a mass of 74.1 grams. You can check what that temperature is. And it looks like the initial temperature of the water is 20.0 degrees. I think our metal is ready, so let's mix them together. And I think we're good there. So the final equilibrium temperature of the metal and the water, 26.2 degrees. All right, so you can do those calculations and let me know the identity of that second metal in the comments. All right, I hope you enjoyed that lab. Remember to let me know the identity of those two metals in the comments by looking up their specific heat capacities. And don't forget to subscribe so you don't miss the next experiment.